Now, if you're going to be doing an experiment, there's one of two basic research designs you can use. They're called the within subjects design and the between subjects design. So with the within subjects design, what you're basically going to be doing is getting different sets of scores obtained from the same group of participants. And then, well, to put it another way, you're going to have a single group of participants who will experience both conditions, so the experimental condition and the control condition. On the other hand, if you want to do a between subjects design, now you're going to get a set of scores from different groups of participants, and each group will only experience one of these conditions. So you'll have like one experimental group, and then you'll compare them to a control group. So you can already see one major difference between these two designs, and that is that the between subjects design typically has twice as many people. Now, I wanted to show you this chart just to help you understand exactly how these things compare. So here's the chart. So you have the within subjects design and between subjects design on the x-axis, and on the y-axis you have the experimental group and the control group. So for within subjects design, you have your experimental group, and you want to compare them to a control group. So that comparison is going to be made to the same people. So you just measure the same people in each condition and compare them to themselves. Whereas with between subjects design, you'll get a group of people in your experimental condition and compare them to a group of people in your control condition, but they're going to be completely different individuals. So that's the whole idea. You know, within subjects design, you compare one group to itself. Between subjects design, you compare one group to another group. But they have their benefits and drawbacks. Like when it comes to the between subjects design, you know, where we measure people in only one of these conditions, you could also call this an independent measures design, there are some definite reasons why you would want to use this. Like, the whole point of doing a between subjects design is to see if there's differences between these treatment conditions. In other words, is our experimental group different from our control group? But like I said, there's reasons why you might want to do this. First, one big advantage of doing a between subjects design is that each individual score is independent from all the other scores. In other words, when you measure somebody on a variable, you don't have to worry about how that measurement is going to affect any other measurements you might take. You don't have to worry about what's called multiple treatment interference. And that can be just simply conceptualized as, like, you know, they're getting practice. You know, you keep testing them on some particular measure, they're just getting used to it. Or maybe it can go in the other way. Maybe you keep testing them on something and they're just getting sick of it. They're getting tired, you know, getting fatigued. That's the basic idea. When you measure somebody multiple times, you can have that kind of multiple treatment interference. Fatigue and boredom are big ones that you need to be worried about. But there's also some big disadvantages. So when it comes to doing a between subjects design, as I already pointed out, you're going to need a lot more people. You're going to need effectively double the number of participants you would need if you did a within subjects design. Like, let's just say, for example, you have 3 different drugs you wanted to compare. Well, you would need 3 times your sample size. So if your sample size is 30, 3 times 30 would be 90. And if you want to compare 4 different drugs, now you have to get 120. And you can see how this can quickly become a problem. Another big disadvantage is that you have to worry about individual differences. So this is a big source of confound. You know, the fact is, when you do a between subjects design, participants in group A are completely different from participants in group B. And those personal characteristics that differentiate them could be a source of confound. And that might produce a high amount of variability in your scores. So when it comes to these kinds of things, between subjects design, it clearly is a good choice, and a lot of researchers use it, but you do need to worry about these kinds of things, and there are things you can do about it. Like, there are at least 3 major procedures for limiting the effects of the individual difference confounds. And researchers usually use at least one of these 3 when they are developing their study. The first one is random assignment, so just randomly assigning participants to groups. The second one is matching groups, so matching across conditions, matched assignment. And then the third one is holding variables constant. Now, if this stuff sounds familiar, it's because we've actually talked about this in the previous video. So this is just a little bit of a review, and we'll just go through it a little bit faster this time, because I just wanted to remind you the whole point of doing this kind of stuff is to deal with individual difference confounds. So first of all, you have random assignment. So this is just when we use some random process to decide which participant is tested in which condition. This is the most common way to deal with individual difference confounds. Because as I said in the previous video, when it comes to trying to, make sure everything is nice and balanced, you can spend a lot of time and effort to make sure everything is, perfectly balanced. But simply leaving it up to chance, simply using some kind of randomization procedure, that usually works out. Of course, there's no guarantee, but it usually works out well enough. And that's why most researchers prefer it. It's quick, it's easy, and it's usually very effective. But yeah, that is one of the big drawbacks of random assignment, is that you can never be completely certain that your groups are going to be well balanced. But, we usually just assume that they are. The second procedure you could do if you want to make sure those groups are completely balanced is matching groups, or matched assignment, where you assign participants to groups so that you have equal looking groups. Like, if you look at my little smiley faces down here, you can see that my smileys on the left match the ones on the right. I have the equal number of blues, I have the equal number of oranges and reds and greens and so on. So I want to make sure my groups have equal distributions of these different variables that I'm interested in. But you don't want to match across everything. As I said before, you can go a little overboard when it comes to this kind of matching. So what you really want to do is you want to try to identify variables that are the most important, the variables that are the most likely to present confounds, and match across those. So if you think age might be a confound, you could match across age. Gender, you could match across gender. But you don't want to take it too far. You don't want to try to do too much matching, because it'll just become too difficult to get those kind of equal distributions. Now, the third way that you can deal with individual difference confounds is by holding variables constant. So what we're basically saying here is that you're trying to keep a confound from being variable. You're trying to literally eliminate a variable. And the way you could do that is by, for example, only recruiting male participants, or only recruiting Caucasians, or whatever variable it is that you think might be a confound. You just make sure everybody has the same level of that variable. But that can be problematic. Obviously, that presents some problems. We talked about those before. So instead, what you might decide to do is just restrict the variable's range. Instead of holding it perfectly constant, you just restrict its range a bit. For example, as a researcher, if you suspect intelligence might be a confounding variable, you could limit its effects by only selecting participants that have a particular range of IQ score. So those are some of the basic ways that you could deal with individual difference confounds, which is, as I mentioned before, the biggest downside, the biggest disadvantage of doing a between subjects design. Now, When it comes to doing any kind of experimental design, whether it's between or within, you're going to have a treatment group and a control group. And in the between subjects design, these are completely separate conditions. These are completely separate groups of people. And when we talk about this treatment group and control group, here's what we mean. So the term treatment condition, that refers to a group of participants who have received the experimental manipulation that you're interested in. You could also call them the experimental group or whatever you'd like, but the whole idea here is these are the participants that we want to look at the hardest. These are the participants that we're the most interested in. You know, they're the ones that are getting this new medicine you developed, or they're the ones that are trying out this new diet you're working on. Whatever manipulation is you want to study, they're the ones that are going to get it. And then the other group is the control condition. So this control condition, this control group, that refers to just a group of people that you also study, but you do not manipulate. So the whole point of having a control condition is to have something to compare your treatment group to. You want to make sure that that control condition is as similar to the treatment condition as possible. The only difference is they don't get that manipulation you're interested in. And as I mentioned before, this is the same across between and within designs. So the same group of people can do both. You know, between subjects you have different groups. Within subjects you have the same group in both conditions. And then you have different kinds of control groups. So first of all, there's the no treatment control. So that's exactly what it sounds like. You know, it's a control group. It's this kind of comparison group where the participants don't receive the treatment being evaluated. It's very simple and straightforward, and it might sound like the best option. You know, it makes sense. If you want to have something to compare to, you simply give the treatment to one group and you give nothing to the other group, and that'll make a good comparison. That sounds reasonable, but it's actually got some problems with it. This is, in fact, generally not the way we want to do research. It's not considered a very good kind of control due to the fact that giving a treatment to one group and no treatment to the other group is actually a big difference. You know, just the act of receiving a treatment could be having an effect. That could be a confound. And in a lot of studies that we've done, the belief that they're getting a treatment is a confound. It's called a placebo effect. So to make sure that this placebo effect isn't, you know, producing a confound in our study, we need to use something else. We need to use a different kind of control group. It's called a placebo control, as you might expect. So in this control group, all the exact same things are done as the experimental group. The only difference is the treatment they get doesn't work. You know, that's what placebo means. It's something that doesn't work. It's inert. It's innocuous. So just imagine like you're testing some new medicine. Your experimental group would get the actual medicine, and then this placebo control group would get a pill that looks identical but doesn't have those particular chemicals in it. And the participant simply wouldn't be able to tell the difference. They would believe that they're getting a treatment. And if you do see any improvement in your control group as a result, that's evidence of those kinds of placebo effects I mentioned earlier. That's really all a placebo it is. It's just when the participant believes that they're getting a treatment, so they actually show a response to that belief. It's like a psychosomatic effect. You know, if you think you're going to get better, in many cases you often do get better. This is in fact, this placebo effect, this is actually how most like alternative treatments work. In my other class, in my Psych 101 class, I'd go into great length about things like acupuncture and herbal treatments and homeopathy and stuff like that. The thing that all these different alternative treatments have in common is that their effectiveness is based entirely on your belief. If you don't believe that they're going to work, they won't work. You know, that's the whole idea. For placebo effect to work, you have to believe that it is going to help you. So, when it comes to placebo effects, those can be confounds, as I was mentioning. You want to make sure that they're not presenting a big problem for you. So, when it comes to a lot of studies, especially medical studies, they will have an experimental group, a no treatment control group, and a placebo control group, or sometimes they call it the sham control. And they compare all of these groups to each other, as you can see here. But by comparing the experimental group to the no treatment control, they can see how big of a treatment effect they're getting. By comparing the experimental group to the placebo control, they can see how big of a difference the effect is from placebos. And then finally, by comparing placebo to no treatment, they can get a good measure of exactly how powerful the placebo is by itself. So all three of these comparisons can provide a lot of really good information when doing medical research. But there's one more thing I should definitely mention when it comes to experimental design. You know, when you do this kind of manipulation, when you alter something like a kind of medicine or whatever it might be, you want to make sure that it's having the effectiveness that you think it's having. You want to make sure that your manipulation is working. In other words, you should check your manipulation. So these manipulation checks, these are pretty common, additional measures to just make sure that their treatment is in fact having an influence. So there's a few different ways you can do a manipulation check, but it basically comes down to just two categories, two basic techniques to check to see if your manipulation is working. So the first way is to explicitly measure it. In other words, if you're trying to make your participants uncomfortable, for example, you would just want to ask them, how comfortable are you? So just imagine you put your participants into a room that's a little bit too hot, and then in the middle of the study you just walk up to them and you say, hey, how do you like the temperature in this room? Do you feel a bit too hot? And if they say yes, then you can be satisfied that you have successfully made them uncomfortable. That's the whole idea. You just basically ask them, do you notice this thing? The other way you could check to see if your manipulation is working is in basically an exit questionnaire. So at the end of the study, as the participants are leaving your laboratory, you should just sit them down and talk to them and say, hey, do you remember when we did this? How did that make you feel? And do you remember when we did that? How did that make you feel? So that's the whole idea. It's basically the same thing as the first one I mentioned, except now you're doing it at the end instead of the middle of the study. So manipulation checks are pretty important, especially if you're doing any kind of research that has really kind of subtle effects. In fact, when it comes to doing a manipulation check, there are 4 different kinds of studies that you should definitely include them. If you have these kind of subtle effects or for other reasons. And here's just 4 of the most common situations where you should do it. So the first situation where you would want to do a manipulation check is if you do any kind of participant manipulation. All I mean by that is when it comes to trying to influence individuals, not all people are the same. Those individual difference confounds, they can interact with the treatment you're trying to provide. In other words, not all people are going to be affected the same way when you manipulate them. So it's important to make sure that these people are reacting to your treatment, to your manipulation in the same way, the way you would expect. And then you have that kind of subtle manipulations thing I was talking about before. Like if you have some kind of pill that only makes a slight difference, or if you have some kind of, like if you're making the room only slightly uncomfortable, like if you're trying to measure anything that's really subtle and participants are not likely to notice it, you should definitely do a manipulation check. You want to make sure that they actually noticed this thing, because if your manipulation is so subtle nobody notices it, then it's probably not going to be very effective. The third reason why you would want to do a manipulation check would be if you do some kind of simulation. We talked about simulations last time. I talked about a couple different kinds of realism when it comes to simulations. If you remember, we talked about mundane realism, which is basically like the graphics, you know, how accurate does it look to the real thing. But then there's that experimental realism, which you could also just call immersion. So if you do a simulation of any kind, you want to know about those two different kinds of realism. You want to know if the participants felt like it was the real thing and they felt like they were in that situation, if they felt immersed in this simulated environment. And then the fourth situation why you would want to do a manipulation check would be if you did any kind of placebo. Because remember what I was saying about placebo. Participants need to believe that the placebo is a real treatment. If they don't believe they're getting a treatment, the placebo's not going to be effective, right? So whenever you do start handing out those placebo medications, those sugar pills or whatever you want to call them, you want to make sure your participants think it's real. If they tell you they know that this is just a fake thing, then it's not going to work. So you should definitely check to see if they believe that it's real. All right. So that's all I really have to say about between subjects design. And a lot of the stuff I mentioned there also applies to the within subjects design, like the stuff about placebos and whatnot. But let's move on. Let's talk about stuff that is more unique to the within subjects design. So this kind of design, these kinds of within subjects experiments, or you could call them repeated measures experiments, this is where you take one group of people and you measure them under all conditions. So all participants are measured under all conditions. And as I was saying, this allows you to have a much smaller subject pool as a result, because you're just comparing one group to itself. Now, there's a lot of big benefits to doing a within subjects design. Like all of the stuff we've been talking about when it comes to individual difference confounds and how to control them by like matching across groups and using randomization. All that stuff, you could forget about that. That stuff doesn't matter anymore, because clearly we don't have to worry about individual difference confounds anymore. We have identical groups. Our groups are exactly the same. Obviously they're going to be the same because you're just looking at one group of people multiple times. So you don't have to worry about those kinds of things anymore. But there are some things you do need to worry about. Those things are order effects. So there's many different kinds of order effects. But order effects just basically refers to the way the order of measurements in your study, when the experience of being tested in one treatment condition has an influence on the participant's score in a later treatment. So there's lots of examples of how this can be a problem, but just imagine, for example, you want to test a new headache medicine. So you give participants a measure, like a control measure before you give them the drug, and then you give them a actual experimental treatment later. So you measure the control first, and then you come back later and you measure the experimental condition. Well, time has passed, and as it tends to go, people's headaches do tend to go away on their own. So simply the passage of time, that might explain why your participants apparently showed a treatment effect. So that's just one example, but there's many. Like, we can break them into different categories. Like, you have something called carryover effects. So that's where one treatment condition produces a change in your participants, and that change carries over. You know, it continues to affect them in later treatment conditions. And then there's progressive error, where changes in a participant's behavior or performance that are related to just general experience in research. It's not really related to any particular treatment or treatments. Progressive error might sound a little confusing, but it basically refers to just things like practice. You know, when you measure people multiple times, eventually they're going to get used to it and they're going to start responding a bit differently. If somebody's an expert participant, they're going to react quite different from somebody who just got started, right? Or, as I mentioned before, it could go the other way. Participants might just get bored of being measured again and again and again and just get worn out and fatigued. But there's things you could do about this. To deal with order effects, you can do something called counterbalancing. That's where you change the order in which the treatment conditions are applied from one participant to another. And then you want to match across those kinds of treatment conditions. As you can see in this illustration down here, one group of participants got condition A first and B later. And the other group got B first and then A later. That's the whole idea. We have, even though it's within subjects and everybody experiences every condition, half the participants get condition A first and half the participants get condition B first. The whole point of doing counterbalancing is to have every possible order of treatments in an equal number so the participants can be easily compared and that order of treatments can be like factored out. So that's the whole idea here, is we want to factor out the order of treatments. We want to eliminate those kinds of time-related problems, which can be real problems. They can be serious confounds in your research. So counterbalancing within subjects design is incredibly important. Whenever you do it within subjects design, this is something you should strongly consider, because it will help you to prevent those order effects, which could have a profound, confounding effect on your study. What counterbalancing basically does is it doesn't really eliminate the order effect confounds, it just spreads them evenly across all treatment conditions. So all treatment conditions are going to be affected evenly by things like practice or fatigue or whatever. And when you spread it evenly like that, it's much easier to just kind of factor it out, to just ignore it. It could still be a problem, but it's not as big of a problem as it would be otherwise. So yeah, I just want to make that clear. When you do counterbalancing, you do not eliminate the order effects. You just make them less, meaningful. You make them less of a problem. So that's kind of the whole point of doing this counterbalancing, is to try to distribute those order effects evenly. And as I said, this doesn't eliminate the problem, but it does spread it evenly, and that even spread will potentially introduce some variance into your study. It'll just make the data a little bit more chaotic, a little bit harder to understand. Usually this isn't a big problem, but this kind of variability, this kind of variance in your data, it can just make things hard to see, make things hard to notice when you're looking at the data later on. So there's other kinds of things you can do. There's other techniques you can do if you're worried about, this kind of variance affecting your data. Like you could do something called a simultaneous within subjects design. So this is a study design wherein the trials for each condition are intermixed. What this basically allows you to do is allows you to have the participants experience all conditions at the same time. Obviously not at the exact same time, but you're trying to get them to experience treatment and control as simultaneous as possible. And as you can imagine, that would be wonderful if you could do that. That'll help you to avoid numerous potential confounds, such as carryover effects. And here's how that kind of simultaneous within subjects design might work. If you look down here at the bottom, you have one trial of condition A, one trial of condition B, another trial of condition B, and then we go back to A, and then B, and then A, B, B, A, B, and so on. You just keep alternating randomly between the two. That's how this with simultaneous within subjects design works. So that can be a great way to handle, things like carryover effect. Now, when you think about between subjects design and within subjects design, they do have their advantages and their drawbacks, and it might be a little hard to decide exactly which one would be best for your study. In fact, most experiments could be either. It's just kind of a preference thing, which one you think was most appropriate for your own research. But there are ways to help you figure out which one might be the best. To determine which design should be used, you should basically just think about the confounds. Which confounds do you think might be more problematic for you? If you're worried about individual differences, then you should do a within subjects design. Like if you think things like ethnicity or gender or age, if you think those kind of individual differences might be a problem for you, just do the within subjects design and you'll completely eliminate that problem. If, on the other hand, you're more so worried about things like practice and fatigue, those kinds of carryover effects, then you should do a between subjects design, because that will allow you to measure everybody literally at the exact same time. Therefore, you don't have to worry about these time-related problems.